Good morning and welcome to this next lecture on vibrations of plates and shells. This is where we left off. We had just formulated the variation of the kinetic energy term here, and this is the variation of the energy from the external loads, and we were just looking at the boundary terms. So, we had written one boundary term which comes up at alpha 2 constant edges then I had gone ahead and showed you an element of a curved shell and all the resultants. So, here I showed you the force resultants, and here I showed you the moment resultants. So, these resultants will come up in the derivation of the Hamilton's law as shown in the small example of the Euler-Bernoulli beam. When we do integrations with respect to thickness. Okay. So, let me add the second boundary term also. Okay. So, the second boundary term, so let me write it once again. EB is equal to integral of alpha 1 n to 2 conjugate u2 plus n to 1 not conjugate star, okay, star, it is not a complex number. Star denotes what is prescribed. Okay. The prescribed resultant from outside the system plus m to 1 conjugate beta 1 a1 d alpha 1. So, this happens at alpha 2 constant edges and plus an integral alpha 2 n11 star u1 plus n12 star u2 plus q13 star u3 plus m11 star beta 1 plus m12 star beta 2 into a2 d alpha 2. This is at alpha 1 constant edges. Okay. So, the picture was drawn for that purpose. Okay. So, these are the alpha 1 constant edges and these are the alpha 2 constant edges. Okay. Along this alpha 2 is a constant, along this line alpha 2 is a constant, along this alpha 1 is a constant, along this alpha 1 is a constant. Okay. So, now what is the term that enters the Hamilton's law? The variation. Okay. So, this is going to be integral T1 to T2 integral alpha 1. Now, these are all prescribed, that means they are all given. The star quantities are given, you cannot change them. Okay. They are coming from outside your structure and they are given. So, now the variation will end up on the displacement. So, you get n22 star delta u2 plus n21 star delta u1 plus q23 star delta u3 plus m22 star delta beta 2 plus m21 star delta beta 1 a1 d alpha 1 dt plus integral t1 to t2 integral alpha 2 n11 star delta u1 plus n12 star delta u2 plus q13 star delta u3 plus m11 star delta beta 1 plus m12 star delta beta 2 a2 d alpha 2 dt, where star quantities are prescribed. Now we have to move to the strain energy. Okay, the strain energy term is the last term in the total derivation. Okay, so let us say the du over a small differential element is 1/2 sigma 11 epsilon 11 plus sigma 22 epsilon 22 plus sigma 12 epsilon 12 plus sigma 13 epsilon 13 plus sigma 23 epsilon 23 plus sigma 33 epsilon 33, but even at this point we will drop this term because it is 0 for us. Okay, and the volume differential, where dV is given by A1 A2. Okay, at this point I am going to put these terms in. We said in our whole theory that alpha 3 by R1 and alpha 3 by R2 we are going to ignore. D alpha 1, D alpha 2, D alpha 3. So the total strain energy is the integral over all the dimensions of the structure, okay, times F dV, where F is given by 1/2 sigma 11 epsilon 11 plus sigma 22 epsilon 22 plus sigma 12 epsilon 12 sigma 13 epsilon 13 plus sigma 23 epsilon 23. Okay, and the way this enters the Hamilton's law, the variation delta u dt, okay, so is equal to integral t1 to t2 integral over alpha 1 integral over alpha 2 integral alpha 3 delta f dV and dt. Now, from here what is delta f? Delta f is del f by del epsilon 1 1 delta epsilon 1 1 plus del f by del epsilon 2 2 delta epsilon 2 2 plus del f by del epsilon 1 2 delta epsilon 1 2 plus del f by del epsilon 1 3 delta epsilon 1 3 plus del f by del epsilon 2 3 delta epsilon 2 3. Okay. So, now let us look at this term here. Let us look at this term here. So, we have del f by del epsilon 1 1 delta epsilon 1 1 given as 1/2. If you look at f, it is del sigma 1 1 by del epsilon 1 1 epsilon 1 1 plus sigma 1 1 plus epsilon 2 2 del sigma 2 2 by del epsilon 1 1 delta epsilon 1 1. Okay. Now, my sigma 1 1 is equal to E over 1 minus mu squared epsilon 1 1 plus mu epsilon 2 2 and sigma 2 2 is equal to E by 1 minus mu squared epsilon 2 2 plus mu epsilon 1 1. Okay. So, that this term here becomes equal to 1/2 E by 1 minus mu squared epsilon 1 1 plus sigma 1 1 plus epsilon 2 2 E mu by 1 minus mu squared delta epsilon 1 1, which is equal to 1/2 E over 1 minus mu squared, okay, epsilon 1 1 plus mu epsilon 2 2, okay, into 2, okay, delta epsilon 1 1. This itself is 1 sigma 1 1 and there is 1 sigma 1 1, okay. So, we get sigma 1 1 delta epsilon 1 1, okay. Similarly, for all the terms we get T1 to T2 delta u dt as integral T1 to T2 integral alpha 1 integral alpha 2 integral alpha 3 sigma 1 1 delta epsilon 1 1 plus sigma 2 2 delta epsilon 2 2 plus sigma 1 2 delta epsilon 1 2 plus sigma 1 3 plus sigma 2 3 epsilon 2 3 A1 A2 d alpha 1 d alpha 2 d alpha 3 dt. Please notice that these terms have been dropped. As they are much smaller than 1, they have been dropped. Okay. Now we have epsilon 1 1 we have epsilon 1 1 given by 1 over A1 del alpha 1 U1 plus alpha 3 beta 1 plus 1 by A1 A2 del A1 by del alpha 2 U2 plus alpha 3 beta 2 plus U3 by R1. And so delta epsilon 1 1 is given by 1 by A1 del alpha 1 delta U1 plus alpha 3 delta beta 1 plus 1 by A1 A2 del A1 by del alpha 2 delta U2 plus alpha 3 delta beta 2 plus delta U3 by R1. Okay. So the first term in here, looks like integral T1 to T2 integral alpha 1 integral alpha 2 integral alpha 3 sigma 1 1 delta epsilon 1 1 A1 A2 d alpha 1 d alpha 2 d alpha 3 dt given by integral T1 to T2 integral alpha 1 integral alpha 2 integral alpha 3 sigma 1 1 1 by A1 del alpha 1 delta U1 plus 1 by A1 A2 del A1 by del alpha 2 delta U2 plus delta U3 by R1. These are the terms that do not contain alpha 3. Then come these terms with alpha 3 explicitly. Sigma 1 1 1 by A1 del alpha 1 delta beta 1 plus 1 by A1 A2 del A1 by del alpha 2 delta beta 2 A1 A2 d alpha 1 d alpha 2 d alpha 3 dt, which is equal to we will take a1 a2 inside, integral t1 to t2 integral alpha 1 integral alpha 2 integral alpha 3 sigma 1 1 a2 del del alpha 1 delta u1 plus del a1 by del alpha 2 delta u2 plus a1 a2 delta u3 by r1 plus alpha 3 sigma 1 1 a2 del del alpha 1 delta beta 1 plus del a1 by del alpha 2 delta beta 2 close d alpha 1 d alpha 2 d alpha 3 dt. Okay. Now we will effect the integral with respect to alpha 3. None of these terms depend on alpha 3. This is a1s and a2s are always the mid surface properties, okay, and u1 u2 u3 the small ones are again mid surface properties, and u3 is uniform across the thickness. So alpha 3 comes in explicitly here and in sigma 1 1. Okay, alpha 3 doesn't come anywhere here. So we will do the alpha 3 integral. If we do the alpha 3 integral, this here only there is only a function of alpha 3 over here. So this becomes the N11 force resultant. Okay, sigma 11 varies across the thickness. So if you integrate it, you get N11. Similarly, if you multiply by alpha 3 and integrate it, you will get the moment resultant M11. Okay, so let us do that. So I get, after doing the alpha 3 integral t1 so is equal to t2 integral over alpha 1 integral over alpha 2 N11 a2 del alpha 1 delta u1 plus del a1 by del alpha 2 delta u2 plus a1 a2 by r1 delta u3 plus M11 a2 del alpha 1 delta beta 1 plus del a1 by del alpha 2 delta beta 2 d alpha 1 d alpha 2 dt. Now these are the variations, okay, delta u1, delta u2, delta u3, delta beta 1 variations of the kinematic variables, okay, and some of them you see have derivatives. This thing has a derivative, this term has a derivative. So now we are going to transfer the derivative onto the other term, okay. So let us take the first term. We have, just looking at the special integrals, N11 a2 del alpha 1 delta u1 d alpha 1 d alpha 2 is equal to the boundary term, which is integral alpha 2 n11 a2 delta u1 d alpha 2 at the ends of alpha 1, okay, minus integral alpha 1 integral alpha 2 del alpha 1 n11 a2 delta u1 d alpha 1 d alpha 2. Okay, a similar term will emerge from here, a boundary term and an integral term. Now at this stage the book somehow switches signs on the original Hamilton's principle. So what you get is t minus a u plus the boundary term plus the loading term, external loads dt. Okay, so if we do this for all the terms, okay, if we put together now all the terms, we will get, that means wherever possible, I mean do the alpha 3 integrals, get your moment resultants and force resultants, and further do the derivative transfers. If you do that, you will get integral t1 to t2 integral alpha 1 integral alpha 2, okay, del alpha 1 n11 a2 which we found, okay. Then from other terms also you will get del alpha 2 n21 a1 plus n12 del a1 by del alpha 2 minus n22 del a2 by del alpha 1 plus q13 a1 a2 by r1, and if you remember the inertial term came with a negative in t, okay, and so here t has a positive sign, so we will get the external load minus rho h u1 double dot a1 a2, okay, delta u1, okay. So boundary terms have not yet come. So this is constituted of kinetic energy, strain energy and the energy from the external load, and all terms are collected that have delta u1 as the coefficient. Similarly, it is going to get horrendous if I write everything. So you will get a bunch of terms that have delta u2, the coefficients to delta u2, then you get a bunch of terms, if you collect, okay, coefficient to delta u3, and a bunch of terms that are coefficient to delta beta 1, and a bunch of terms that are coefficient to delta beta 2. D alpha 1, D alpha 2 dt. These are the integral terms. Further you get the boundary terms. Okay. So you can see here that in the u as was derived, this boundary term is positive, okay, but now u has a negative over here, okay, and the boundary terms that are actually forced from the boundary, they have positive numbers. So with this sign here, you will get t1 to t2, the boundary terms now, integral alpha 1 n to 2 star minus n to 2 delta u2 plus n to 1 star minus n to 1 delta u1 plus q to 3 star minus q to 3 delta u3 plus m to 2 star minus m to 2 delta beta 2 plus m to 1 star minus m to 1 delta beta 1 a1 d alpha 1 dt. These are at alpha 2 constant edges. Plus, let me go to the other page. I'll write it. I'll try to squeeze in here so that you have everything here. Plus integral t1 to t2 n11 star minus n11 delta u1 plus n12 star minus n12 delta u2 plus q13 star minus q13 delta u3 plus m11 star minus m11 delta beta 1 plus m12 star minus m12 delta beta 2. Okay, there is an alpha 2 integral. Let me do this. Integral t1 to t2 integral alpha 2, so there is a plus sign here and closure here, a2 d alpha 2 dt. This total thing must be 0. This is at alpha 1 constant edge. Okay, this total sum must be 0. Okay, now here the beta 1 beta 2 definitions have to be used. Beta 1 beta 2 definitions that make epsilon 1 3 and epsilon 2 3 equal to 0 have to be used. Okay, now out of this you can see that you will get 5 main equations. Okay, you will get 5 main equations. I will just most likely write them once. So you get 5 equations. these are minus del alpha 1. I am writing it as the book says it, okay. Del alpha 2 and 2 1 A1 minus N1 2 del A1 by del alpha 2 plus N2 2 del A2 by del alpha 1 minus A1 A2 U1 3 by R1 plus A1 A2 rho H U1 double dot is equal to A1 A2 Q1. Time has run out, so I will stop this lecture here and continue from the next class. Thank you.